Hello. All right, a little bit about me. So I've been writing Go for about 4 years. Currently software engineer at Twitch. So Twitch, if you're unfamiliar, we like stream video games. Most of our backend at Twitch is written in Go. There's probably hundreds of miniature Git repositories that we use for various different microservices. And I kind of like to think that because of the vendor experiment where you have to copy your code into your repository, we grow lines of code big O n squared. So we may be more lines of code than even Google, just because you have to copy all the code into every repository. So mono repos can't keep up with their big O n asymptotic time. So I'm going to break this talk into kind of three sections. The first section is going to kind of explain context, what it does, how it's kind of built, and context itself is mainly two different things. One of them is about request cancellation, and the other is this added part called context.value. So I'm going to kind of talk about each of those separately and give you best advice on like how to use it, when to use it, the right way to use it, the wrong way to use it, and hopefully you'll learn a lot. So why does context exist? So that's kind of like step back a bit. This would be the experience report for context. So ideally, every long request that your service is going to do should have some way to time out or end that long request, right? So like context doesn't exist yet. Let's just think about the problem there. So your service is doing microservice calls. You want to time out those requests, right? Or you want to cancel them early. So there needs to be some piece of information that kind of holds that timeout. And maybe your request comes into your microservice or your HTTP server and you say, all right, I don't want to take more than 3 seconds. And you're kind of further down your call stack, like how much longer do you have left for this second call that you're doing, like 10 or 20 RPC calls down the stack. So you kind of need to store that somewhere. You kind of need some place to communicate that. And the problem gets a little bit expanded if your service is making multiple RPC calls in parallel. So what I have here is kind of like a simple diagram of a request comes in, right? It does one RPC call to get some information. And then from that, it's going to spawn 3 concurrent RPC calls and kind of aggregate that information and then spit out a result. So an example of this might be someone requests something from your site. So you go to the user database, you get like user information, and then you kind of populate various parts of the user from different microservices and combine that into one big request, right? So everything's working great. This request takes 40 milliseconds. Everything's perfect. You still don't need context, right? What if RPC2 fails? So usually, when your service is doing microservice calls, one part of it fails. You can't really assemble that request that the user wanted, so you have to fail the request that the user gave you. But the problem here is that RPC2 fails at 30 milliseconds, but you're waiting till RPC3 finishes and your request takes 40 milliseconds, even though you probably should have just failed it at 30, right? So you say, okay, I'm just gonna like end my request right when RPC2 ends, right? So RPC2 ends, you're gonna say, I can't make this request because one of my microservices failed, so I'm just gonna fail the whole thing. The problem with this is that you have RPC 3 and 4 still doing computation, still going out there, consuming resources, right? When you can't really do anything with that information because you can't give the user a response when RPC 2 failed. So the ideal situation would be, all right, if RPC 2 fails, maybe I can kind of communicate that to my parallel request and say, all right, you should stop doing whatever you're doing because I don't really need your response anymore, and then return like an error to the user. So this is kind of the bigger problem that creates how the context solution created. So if you were to solve this in Go, you'd probably have some object to signal when a request is done. You'd probably need hints on like when the request is going to end. And of course, being Go, like you have to throw channels in an API because why else would you write Go? That's a joke. And then someone was like, well, we got this thing, and they don't really want to add Threadlocal information. I know, let's just like shove variables in there too. I don't know, that happened. So I'll kind of talk a little bit about that. You could argue that request cancellation is a subset of the variable problem, right? Because the cancellation itself could be a Threadlocal variable. So context implementation details, it is a tree. So a tree is a graph without cycles. A tree of immutable context nodes. And cancellation triggers down the graph, and value lookup triggers up the graph. So I'll give you like an example of one created. So this is just an example of context chain. There's like a background context, which is the root of all your context chains. And you say, all right, I'm going to make a context that can cancel, and then from that make a context that times out in 5 seconds, and then from that make like 2 other contexts, and then from that attach user data. Not too much, not too important to kind of read the code. Just kind of going through the way it works. After 3 seconds, this context chain obviously times out the 3-second node, so the 3-second node says it's done. At 5 seconds, the 5-second node times out, but which may be less intuitive is that the 6-second node also times out because it is a child node of the 5-second node, right? And then the value node also times out because it's a child of the 6. All right, so the API that is created, it has 2 areas. One of them is 3 functions that are going to give you basic when to end your sub request information. So the done and the error are the 2 main ones that I honestly use myself. The deadline one may or may not be there, but it's basically there if you make a timeout context and you want to time out an IO operation. So you say, oh, this context is going to die in 2 seconds, so just set the timeout on my IO operation to 2 seconds to be done. And then it's got this extra thing about request scope variables, which I'll talk a lot about later. So when should you use context? That's interesting. So stepping back from context a bit, it certainly makes sense, and that I think we could all agree that any RPC call you make should have an ability to time itself out, right? Because if you're writing a library and it's part of an RPC call, it just makes sense to give your user an ability to stop that call, right? And not just timeout, but remember the RPC 1, 2, 3, 4 example I showed before. You don't want to just time out an RPC call. You also want to be able to preemptively cancel it early if something weird happens and you're like, oh, I don't even need that information anymore, right? So any API that you're going to design should have that ability. Context is the Go standard way to communicate that information. So how do you create a context? That's the first thing you do. I would call context.background at the beginning of every RPC call. So one way I've seen people do this that I would consider not necessarily the right way to do it is to call context.background in your main function and then attach that context to like a server that creates derived context from it. That's kind of weird. Ideally, you're just calling context.background. RPC call comes in, and you call context.background, and then you kind of like thread that context through. How do you integrate it into your API? So there are 2 common ways to put context into your API. One of them is if you just have a raw function call. So the first thing I have there, that both of these are in the standard library. The first one is in the dial function, so you're like dialing an address, right, to connect. And the context there is the first function, the first parameter of a function call that might block. The other way to do context is when you attach it to something called a request struct. So the request struct pattern is often used when the parameters to a function would be so large that you want to just make a struct out of those parameters and then execute things on that struct, right? So you could imagine if Go had keyword arguments, maybe you would need a request struct, you would just kind of keyword them all. But like with HTTP, there's dozens of things you can set, so it wouldn't make sense to kind of have like an HTTP function with like dozens of parameters, so you kind of want to make a request struct out of that. So I believe that's the reasoning there, and you can attach context to your request struct. And you should probably name your context CTX, just because that's what everyone does. And you want to be like everyone else, right? Where to put the context? So the mental image I would give the context variable is flowing water in a river, right? So water in a river doesn't stagnate anywhere. That would be like, don't drink that water. It just kind of flows through. And your context should live with your call stack. So I don't mean like call stack versus heap necessarily. I mean, you know, a RPC call comes in, you've got your context, your call stack goes up and down, and then your call stack goes back up. Ideally, the context kind of goes away with it. So it's not like referenced by anything. It's not sticking around. The one exception of putting it on the call stack is when you need some kind of like request struct, and you're maybe passing that request struct to a channel, or you're passing that request struct to like the http.request. In that case, it's okay to attach it to a struct instead of like having it as a variable that's kind of passed around. But in that very specific use case of attaching it to a request struct. And your context dies when your request dies. So they're like married together, and until death do they part. And the request dies, context dies too. One big caveat about the context package is I would get in the habit of closing any context you create. So contexts don't actually have a close function. They have, when they can be closed or canceled, they return a cancel callback. Get in the habit of calling that cancel callback, even in the case when you're done with your RPC call. One reason is that when you create a context with a timeout, internally it uses something called afterfunc, and this afterfunc won't garbage collect until the timer executes. And so you don't want this thing sticking around for a full second or a full like year if you have a misconfiguration when your request is done in like 10 milliseconds, right? So the cancel context doesn't have this issue, but I would get in the habit of closing your context when you're done with them. So always close them. And I kind of had a mental note there on the third bullet point. If you could think of it as if your context gets garbage collected and it was cancelable and you never canceled it, that's like a chain of events that should not happen. Request cancellations. Let's go into it. When do you cancel something early? So I'm going to kind of deep dive into the error group package. It's a really awesome package that puts a very easy to use abstraction around context that at least most code at Twitch uses when it makes parallel requests or a concurrent request. So let's deep dive into it. So when you create an error group, it's this struct. It's got a bunch of private variables in it, right? So you're probably not going to make the struct initially. You're going to make it with this thing called with context. And it's going to create a cancelable context and give you that context back. So the idea is that you're going to now do operations with that context, and you're going to tie parallel or concurrent request with that error group. So rather than call the go keyword, you would call the go function on the error group, which is going to internally call the go keyword with some wait group wrapping. And the important part of this is it will execute your passed in function. And if your passed in function returns an error, which in this API means that like something weird happened, so you probably don't need the other stuff, it will cancel the context that was stored in the error group, and it will do that sync.once. So only once will it cancel that context. And it actually stores the first error you got back as something you will later return when you wait. So the idea with error group is you make an error group, it gives you a context, and then you use that context for as many parallel calls as you want, right? And you call wait, and wait will block until either it gets in, it'll block until the wait group is finished. And your wait group should finish on the first error if all of your parallel requests are respecting context. Oh my goodness, what is this? So I'm not going to go like fully into this. I'll kind of leave it up there a bit to, I guess, absorb, and maybe you could like look at it later. But this code is doing a lot of like very complex stuff in a short few lines of code. So what I'm doing here is I'm executing two requests at the same time. One of them is a fast request, obviously by the name. So this is obviously a great way to optimize your API. You just rename it to fast request. No, then they'll file a bug report. No. You rename it to slow request, so when it's slow, you just say, well, obviously. Fixed. So it's executing two requests, a fast request and a slow request, right? And it's going to execute both of them at the same time. And if either of those requests return an error or a 500 error code, or I guess anything above a 500, they return an error and it should cancel the other request if it's still taking a long time. So you could imagine inside a similar pattern, you're executing multiple requests at the same time, and you're thinking, oh, how do I time these requests out? I don't really get it. Just use the error group abstraction, and it makes it pretty easy to kind of time out and return the first error you get from all of them. So this is how I do almost all of my concurrent requests. Okie dokie, request scoped values, oh boy. The API duct tape. So is duct tape like a universal meme, or is it just kind of like a southern thing? I'm not really sure. If you're unfamiliar with duct tape, it is this great thing that fixes everything. One of my story time, one of my first memories involves my dad, duct tape, and the brakes on his truck. And I was too young to remember how, but I just remember my dad, the truck, and duct tape, and brakes, pads. So I don't know, it really can fix everything. Stepping back, I mean that sarcastically. But a lot of people use context.value as duct tape. So this is the implementation of context.value. It's pretty simple. It has an embedded context parameter to the struct, so it kind of inherits all the context functions, and it just changes the value function to check its current value, and if it's not there, just kind of pass it down the chain. So using this embedded context is how most of the internal contexts are actually implemented. So advice number one is to scope your key space. So context.value, you don't want to pass in just a string or an integer, because another package might, for some reason, use the exact same string or the exact same integer, right? So to scope it, you do four things. You create a private type. So the private type is a way to make sure that no one else creates something that looks like your private variable, right? So create your private type, then create a private variable of that private type, and then you expose getters and not setters. So I call them with rather than set, and the reason for that is context is supposed to be immutable, right? So if you use the word set, it kind of implies not immutable. But if you use the word with, then it kind of implies, oh, it's making a context with this thing rather than setting something on a context. So as an example, you have a request ID, and you can either get it from the context or create a context that has that request ID in it. Context.value should be immutable. So this is another important part. So the context package is designed immutable. So all of it's immutable. When you create a context that has a 5-second timeout, you can't change that to 3 seconds. It's 5 seconds. If you want a 3-second one, you make another one that maybe inherits from it. So you should keep that philosophy with context.value. So I would not store a value that you expect people to mutate directly. That kind of goes against the immutability idea that context has. And you don't want to store a value that can't be accessed thread safe or in a concurrent way, because that's not going to really work, because the whole point of context is to ideally be able to do it in lots of different Go routines. What do you put in context.value? So you put request scoped data. So what is a request scoped value? Request scoped value is something that is derived from information in the request, right? And information that goes away when the request is done. So that's a pretty broad definition. Let's kind of give some examples. What is clearly not request scoped? So anything you make in func main is clearly not request scoped, right? Because you made it before you even got a request. So a database connection and some kind of logger you've set up in func main, clearly not request scoped, so don't put it in context.value. But then you might ask the sub-question, what if you take that logger and you attach a user ID to like a sub-logger? Can you now attach that sub-logger to a context? Or if you take a database connection and you kind of attach a request ID or a user ID to that database connection, which is tied to a request, can you now attach that? And I'll get into answers for that later. Stay tuned. So what's the problem with context.value? Everything is a request scope value, which is somewhat ambiguous when you try to figure out how to use it. So you can imagine an add function, right, that just takes a context, because really, why do you need parameters? And if they don't want to give us keyword arguments, but they want to give us context, we'll do it, and we'll just make our own. This is obviously like a really bad idea, right? And if you think back to it, what is request scope data and what is not request scope data? Like almost all your variables in your service are request scoped. Like they come from the request and you probably don't need them afterwards. So it's a pretty broad scope of what you can put in there. So this is why I dislike context.value. This is kind of a summary of some code I've actually seen where someone had a user ID in a context and they wanted to know if the request user was an admin. So they got this like authorization singleton, they got this user ID from the context, and they kind of like returned a Boolean from it. The problem is that it's really hard to tell from the function signature what's going on, right? Because when you're reading code, you're not like going into every single function you read, you're kind of like skimming through the code. If the function signature had instead been is admin user, and it takes a context and an explicit user ID, and an explicit authenticator, it's really, really clear what that function's doing, right? It's really, really clear that the function probably blocks, it's probably cancelable, and it does something with a user and something with an authentication service. So if I want to stub it out or mock it or test it, it's really clear what I need to kind of change. And with the first one, you have no idea. You gotta like actually read the code, and then, oh, you might refactor it, and things get messed up. So big reason not to use context.value. All right, so I get it. It's really bad to use context.value. What can you put in there? It should inform, not control. That's kind of a phrase that I made up, which feels like it fits with the philosophy of context.value. It should never be required input for documented results. And if your function or API won't behave correctly for whatever you kind of think correct is, based on what is or isn't in a context value, then you're probably obscuring your API too heavily. All right, so what things don't control then? Let's give me some concrete examples. Request ID is a great example of something that would easily fit in a context.value, right? So if a request ID is in there, it doesn't matter if it's request 5 or 10 or 20. You're not doing if statements on it, right? Like if it's not there, you know, so what? It doesn't have a request ID. What are you going to do with it? Are you going to like actually do logic on a request ID? So that's probably okay. Logging. So logging is usually not documented into your API, right? It's kind of like this extra thing you say, oh, there's logging, but I'm not gonna like document when I log and where I log. Usually you don't do that. So it kind of fits in. What I would recommend is rather than attach the logger to the context, attach metadata to the context and have your logger extract that metadata from the context. And the reason for that is you kind of separate out the immutable part, and because you can use that request scoped data for other stuff. Like the logger isn't really the request scope thing. Like the request scope thing is the user ID or the request ID that you're logging. Things that clearly do not clearly control, right? So I said inform, not control. Database connections, authentication services. These are things that are very, very clearly super important to your API. They control your logic. So even if your database connection has a user ID on it or a request ID on it, like I would advise against putting it into your context.value because it's probably your code won't work if your database isn't there. I don't know, unless you're like really psychic. So creative debugging with context.value. So there are some creative ways to use context.value. I wrote this blog post, HTTP trace and context debug patterns, that I guess you can now clap on Medium. Like, what is that? Sorry, it's like clap. So HTTP trace, it's built into the standard library. And what it is it's an optional struct that you can attach to your context. And it has function callbacks on it. So I only listed 3 because I only have like slide space for 3, but there's like a dozen of them. For when first byte, first header, like request done, got it from a pool, right? And you can attach information to those requests. And if you look inside net HTTP, way deep inside the request struct, there's this private write function where it will extract a trace from your request context. And if there's a trace there, and you defined a rote headers callback, it'll call the rote headers callback. And this is a really great example of inform, not control, right? So the idea of this struct is not to control your logic on when the headers were wrote. And the HTTP library is not going to do special things based on when the headers were wrote. The idea here is to inform the API user that you wrote headers so that they can like log stuff or trace things or debug why things are failing or things like that. This is another really weird example of request.value. So OAuth 2 uses request.value for dependency injection during testing, I think. I'd never actually seen this before, so I'm not, I would advise against doing it. It seems like it's there mostly for testing, but the idea is that you can attach a client to the context that you call the OAuth functions with, and the OAuth code will kind of look into that context and extract a client out and like use it for stuff. It's very indirect. I would much rather the optional client be on some kind of struct that is part of the request itself. So that's really weird. All right, so reasons people abuse context.value. So I'm very sympathetic to really large code bases with lots of middle layers and lots of middleware abstractions where you're like, oh, I don't know how to put this user ID that I calculate way over here and like fiddle it down way over here. You know, it's like, how do you like rearrange your APIs to do that? And so you just give up, I'll just throw it in the context and just kind of like assume it's everywhere else. So very sympathetic to that. And it feels like your API is cleaner, right? Like it feels like, oh, I don't have to put this user ID in my API and just kind of like throw it in the context. But if it's required logic, then it's still part of your API. You just don't have it as a function signature. It's like this hidden thing inside the context. So I would argue that putting things in your context.value because you don't want to mess up your API actually obscures the logic of your API. And there's ways around this with lambdas, like lambda style functions or callbacks, things like that. So summary of context.value, really great for debugging information. Required context.value parts would obscure your API, so I would kind of advise against those. I believe it is better to be explicit in your API, so make explicit parameters, and try not to use it. Like it has a purpose, so I would go back to inform, not control. And if you're doing inform style operations, then that's like a really great use of context.value. But if you're doing control style operations, yeah. Summary of this. So a lot of information here. Summary, any operation you do that is long or blocking or IO should take a context, right? I mean, it should have some way to stop itself, and context is the Go standard way to kind of do that, so it should probably take a context, right? Error group is a really great abstraction on top of context, so I would strongly recommend using it if you're doing parallel calls. It just makes it really easy to kind of cancel them all at once and time all that back out. Always cancel your context when you're done with them, because you might end up changing that to a timeout context and putting in the wrong value, and now you've got a memory leak really bad. So always cancel your context. Context.value should inform, not control, so don't make it required logic. Scope your context value keys. That's the part where I had like the private variable type. Context itself should be immutable and thread safe, and that should also be true for any values you put in it. And a context should die with the request. So they are married together. When the request is done, the context should all be done too. So that is it. Thank you very much. I have a little time for questions if you have any. Thank you. I think there's a mic back there.
Thanks. Do you use context in the context of like transactions with databases and so on to cancel those as well and keep track of them?
Yes. So we use a lot of different databases at Twitch, and I do attach my context to those requests. But you could argue that it's maybe ambiguous what actually happens if you cancel a database transaction. I normally don't cancel the write ones unless it's totally okay to have like weird data there. But canceling a read operation on a database should, unless you have like a really weird database, it should be okay. So I definitely attach context to all of that. Anything else? Come at me, bro. Sorry, that's jet lag talking. Okay, cool. Thank you.